Hi everyone, welcome back. We are now going to be doing question 4 together. So this is technically our second example problem, but it'll be question 4 in your handy dandy packet that I gave you. So turn in your packet to question 4 and we'll get going on another way to apply similar figures. Okay, so this one says the ratio of girls to boys in a first period geometry class equals the ratio of girls to boys in a second period geometry class. So the ratios are the same, which means we can set up a proportion, which is great. We love proportions, so this is awesome. Okay, so the first period class has 16 girls and 12 boys. So we have 16 girls and 12 boys in the second class, or in the first class. In the second class, we have 12 girls. And I want to know how many boys there are in the second period class. So I'm trying to figure out how many boys there are in my second period class. Okay, so again, when we set up a proportion, it's very important that we set them up in the same exact way. Which it doesn't matter if I start with girls and then go to boys or vice versa. It doesn't really matter. Alright, I'm gonna put boys first. Why not? Okay, so my boys, so I'm gonna do boys over girls both times. So in the numerator, I'm putting the boys, and then in my denominator, I'm gonna put the girls. So girls. Okay, so let's set this thing up. So in my first period class, I have 12 boys, and I have 16 girls. And in my second period class, I don't know how many boys there are. That's what I'm trying to find. So since I don't know how many boys there are, I'm going to put an X for boys because I don't know. And then how many girls? There are 12 girls in the second period geometry class. So 12 girls. Okay, and after you set it up, from here, you simply just solve. So let's get going. Again, you guys, the hardest part about these problems, in my opinion, is setting it up. After we set it up, you guys know what to do. You just cross multiply. Okay, so don't forget, before we cross multiply, I'm going to reduce down any fractions to make my life easier. Okay, which I can already see that 12 and 16 can be reduced down. Do you guys know a number that will divide into 12 and 16? Like normal, of course you guys do. It is 4. So I'm going to divide both of these by 4. So 12 over 4 will give me 3. So I have 3 over 16 divided by 4 is 4. Okay, and that will equal x over 12. So x over, wow, that's a really bad slant. Sorry, guys. Over 12. Alright, and then from here, guess what? We cross multiply. So let's get going. Okay, so I'm going to go this way first. 4 times x will give me a 4x, and that will equal the other way. So I'm going to say, let's see here. I'm going to go this way. So 3 times 12, which is 36. And then from here, we just simplify down. Okay, so from here, I know that there's secretly a multiplication symbol in between my 4 and my x. Okay, so that means the way that I move 4 to the other side is by dividing both sides by 4. Which 4 divided by 4 will cancel and turn to 1. And 36 divided by 4, well, guess what, you guys? That's 9 again. So we got 9 twice, which is pretty cool. But don't forget, we need to include our units or this doesn't make sense. Your answer is gross and naked and disgusting if you don't include those units. So make sure you guys include those units. Okay, so we're solving for how many boys there were in the second period class. So I know 36 divided by 4 is 9. So there are 9 boys in the second period geometry class. And guess what, you guys? That's it. Now, our next 3 examples, these are going to flow more like our previous similar triangle word problems. We're actually going to have triangles that we'll be solving. So the next 3 will kind of be similar to when we did similar triangles. So get ready for that. As always, excellent job, you guys.